So over the past 10 or so years, ERP applications and enterprise applications have moved into public cloud mostly for operational efficiencies. It costs a lot of money to buy equipment, database servers, application servers, and put them in a data center, your own data center, connect them to lots of things, and have that hardware refresh every 3 or 4 years. So CIOs and CTOs decided to go and use public cloud services, infrastructure as a service for the most part, to save money and operational money and be more flexible from a compute perspective and use what they need. Does come at extra cost. Very wise decision, and for the most part, companies were getting value out of that. However, times have recently changed very quickly. Now we have a need for AI, GPUs, and AI outcomes from these ERP and enterprise applications. And also sovereignty has come into play that have made some use of public cloud not as attractive as it used to be. So we also need to account for the fact that it's very difficult to connect the cloud environment at times to all the things that an ERP application needs to connect to in order to function at its highest value proposition. So for instance, I need to connect to my customers sometimes. I need to connect to my supply chain. I need to connect to my other systems and regions. And don't forget my users. Every time I'm connecting and I'm sending data out from this public cloud environment to any of those cohorts, I'm spending money by the gig. That is impossible to budget. So even if you had a number in your budget for this environment, these numbers are impossible to predict. You don't know how much data change you're going to do, how much you're going to send out to a customer, how you're going to, a user's going to pull reports out of the system or bulk data transports. So to instantiate these connections from the outside world into your public cloud environment, it requires these people to be on the same cloud in many cases as you, or that data has to go over the internet. And that has a lot of problems associated with it. Also dealing with sovereignty. So let's frame this problem from an enterprise application environment perspective. So if we've got an entire instance of an application, we typically have multiple environments within that. First is the sandbox. This is a playground where people can try new things in the ERP application to see they can develop new functionality and learn. So there's no production data in there. Then we have a development environment. This is where your developers create those new features for your ERP application and do new things, create new reports, and develop new functionalities. And that's really accelerating now with AI. Again, you're not working with production data here. That's where this ends. After development, and you have your code, that needs to be tested, but that needs to be tested on real data. So now we start to get into a much more compliant and secure environment. And after testing, and you're ready to go to production, first it goes into QA, and after QA, we now get to deploy into production. So it looks like this. And there are literally transports from software from these different environments. These environments may not be in one single computer. They are very often in different compute instances, but they are cobbled together into one big instance of your application. So these do need to talk to each other, and they typically talk to each other over the internet in something called a transport system. Okay? That's great. But here's the thing. These three environments here have sovereignty requirements. They need to be secured. There's financial information in there. There's stuff that can't get to the street if you're a public company for Sarbanes-Oxley. There's all sorts of regulatory compliance requirements for those three. For these two, Dev and Sandbox, synthetic data is perfectly fine, and that's not real. That's based on production data, but it's like it. There's no real data in there. So keeping these in the same public cloud environment starts to not make as much sense when I need to bring to bear on production a lot of resources for AI, and I need to start keeping things sovereign. These forces are making me think I got to do something a little bit different, and I need to open up my options in order to create these outcomes. We still have the public cloud, and the public cloud is good for lots of things. So here we're going to have our sandbox, and we're going to have our dev environment. I don't have real data up here. This becomes a lot easier to manage because I don't have the same controls required. Now, I still want to connect that because I need to transport the changes I make in dev into my other environments that have prod, QA, and test, because I need to transport code into those environments. Okay, so at Equinix, what customers do is they're using Equinix Fabric, and in this case, perhaps Fabric Cloud Router. There are other technologies that you could be brought to bear here as well, but Fabric Cloud Router allows us, and Fabric allows us to connect to multiple clouds and multiple resources. We're going to get to that in a second. But if I connect my cloud environments to my environments here at Equinix, I am able to have these environments have their data and the compute run right out of a highly interconnected and sovereign location. This is on equipment you control in locations you can access. Auditors like this. The other thing they like, and CFOs like, is when I need to go use GPUs for the new AI use cases, I can connect right from my data to these GPU locations. Equinix maintains an ecosystem of neoclouds and GPU as a service vendors. So instead of paying the tokens per dollar up here, I can pay tokens per dollar, much lower amount, and my GPU as a service provider, right? And be able to move my data into these GPUs as a service providers for maximum inference, flexibility, performance at lowest cost. Now, the other thing is that I have the most dense ecosystem of network service providers available to me through Equinix Fabric. And this allows me to connect to all of those cohorts, users, supply chain, data marts, and customers. And I don't have to pay on a per gigabyte basis. These are all flat cost, known deterministic cost and deterministic performance, private interconnection, not over the internet, to all of my users and all these other cohorts that have to use this system, that then use the GPUs and all this other environment. So I have an optimal outcome here, maximum flexibility, maximum sovereignty, and I've solved for, in each region, for my maximum outcome, and I've accounted for AI demand, and I've accounted for sovereignty. So if you want to learn more about how enterprises are future-proofing critical IT workloads like your ERP within Equinix, please use the link in the description below. Thanks for watching.